Assalamualaikum and a good day. My name is Faris and Mohamad. My ID number is TB19021. The objective for this experiment are first to measure the magnetic field of a straight conductor around the solenoid. Second, to measure the relationship of magnetic field and the number of turns. Third, to determine the magnetic field by using the Ampere's law. Okay, next for the introduction, the electromagnet is a magnet that produces the magnetic field by an electric current. The electromagnet usually consists of a wire that wound into a coil and carry the electric currents that produce a magnetic field which close field lines around the wire. The electromagnets are the wire coils which perform as bar magnets with a distinct north and south pole when the electrical current is passed through them. The magnetic field that this charge produces is shown as in the figure 1 below. The right-hand rule is using in determine the direction of the currents and the magnetic field. The magnetic field intensity is also affected by the characteristic of core material used, which is a ferromagnetic, such as iron, nickel, cobalt, or any combination of their alloys. A significant change in flux density will be detected on the coil and is one that can be magnetized. According to the Ampere's law, the magnetic field inside of a long solenoid can be obtained as a function of the number of turns per length, which the currents pass through the solenoid. The Ampere's law is a part of the Maxwell equations. The Ampere's law formula states that the magnetic field is directly proportional with the number of turns and inversely proportional with the length of the solenoid. There is an Ampere's law formula given below. B equal to mu Ni over L. The apparatus and equipment in this experiment are nails, battery holder, AA batteries, the wire electrode, the multimeter, stapler bullets, and the last is the ruler. Okay, next I will show you on how to conduct this experiment on the magnetic field. Okay, let's restart. Okay, first the batteries were put into the battery holder as the power supply voltage. After that, the value of the voltage and the resistance of the wire were measured by using the multimeter. The value of voltage is 3.12 volts and the resistance of the wire is 1.5 ohm, and the result was recorded into the table. Then the stapler of the bullets were placed. Next, the nail was measured to fix the length of the solenoid to 6 cm. For the first, the solenoid was beat by winding the wire with two numbers of turns and connect to the supply voltage and switch on. Then move closely the solenoid to the stapler bullets to magnetize them. For the first trial, 5 of the stapler bullets are magnetized, and for the second trial, 3 of the stapler bullets are magnetized. For this experiment, we repeat the measurement value to 3 times to get the average value. Then for the third trial, 2 of the stapler bullets are magnetized. Meanwhile, the switch of the supply voltage was turned off to demagnetize the stapler of the bullets. By repeating the steps of 6 to 9, the number of turns was increased to 4, and the data of the stapler bullets that magnetized were observed. For the first trial is 9, and the second trial is 6, and the third trial is 6. Next, the number of turns was changed to 6 number, and the value of the stapler bullets that magnetized were measured. For the first trial is 8, and the second trial is 7. For the third trial is 7. After that, the number of turns was increasing to 8. The result for the first trial that the stapler bullet that magnetized is 9, and the second trial is 10, and the third trial is 9. After that, the number of turns that apply to the solenoid is 10. Then for the result that stapler bullets that magnetize is, for the first trial is 11, the second trial is 14, and the third trial is 12. For the last slide, it shows that the result for the number of turns 12, 14, 16, and 18 respectively. Based on the table 1, it shows the result of the stapler bullets that magnetize and value of the magnetic field. The measurement value of the stapler bullets that magnetize for each reading were taken 3 times to get the average value. The number of turns were increasing from 2 to 18 by 2. We can see that the value of the stapler bullets that magnetize is proportional with the magnetic field that produced along the solenoid from 0.071 millitesla to 0.748 millitesla respectively. Based on the right-hand rule, the direction of the magnetic field and current can be determined, which are the right-hand thumb points in the direction of the current, and the direction of the magnetic field around the wire is indicated by the cursed fingers. The current was flow into the solenoid from the terminal positive to terminal negative along the coil, and it produced the magnetic field. Besides that, we also can see that the magnetic field strength along the solenoid produced will be affected when changing the number of turns that winding around the solenoid. Okay, for this slide, it shows the first graph, the magnetic field against the number of stapler bullets that magnetize, and the second, the magnetic field against the number of turns. Both of these are directly proportional to each other. Okay, for conclusion, the objective for this experiment were achieved by measuring the magnetic field of the solenoid by using the difference number of turns and by fix the length. Next, based on the result and graph, the relationship of the magnetic field and the number of turns are directly proportional to each other, as when the number of turns increase, the magnetic fields also increase. For this experiment, the difference value of the number turns that applied give effect to the strength of the magnetic field were observed by using the stapler bullets that magnetize. The more winding of the coil will increasing the magnetize of the stapler bullets. Finally, the value of the magnetic field can be calculated and determined by using the Ampere's law formula. Okay, that's all from me. Thank you.